questions. Of course, as I said though, I am not going to finish all of it, but that's besides the point. Okay, so minimize, there we go. So this is that lovely final exam review sheet. This claims 13 pages, but I slightly edited it so it's a little bit easier to see without having to squint. It was 10 pages long. But anywho, might as well begin with this. With a topic we haven't seen for months. Determine whether the summary measure is best described as a parameter or a statistic. The average weekly amount spent on groceries by a family of 4, based on a random sample of 100 families. By the way, before I answer this, do not just assume that that number is the only thing that's going to change on this. That scenario is also going to change. I did set it up so it does change, so please be aware. You hopefully will not have the same exact question. But because this has, that's the weekly amount spent on groceries by a family of 4 based on a random sample of 100 families. Because, my goodness, because it says that, this is going to be a statistic. And this highlighted part, which you don't need to identify on the final, but I'm just going to just for the sake of convenience. But this is the sample, my highlighted part here. Again, you will not be asked that. The only thing it's going to ask you is a parameter or a statistic. In this case, it's a statistic. Any questions about this? Again, we have not seen this in ages. Alrighty, as I said though, I mean, this one's not going to be, at least I hope anyway, not to be too terrible of a question. As you could probably assume, there are more terrible questions in this actual exam than that. Like question number 2 here. For example, a study was conducted at the end of an introductory statistics course to investigate the relationship between X is equal to skipping class and Y college GPA. The sample regression equation is y hat is equal to 3.60 minus 0.0896x. The sample slope, b, is equal to negative 0.0896, has a standard error of 0.026. We want to construct and interpret a 90% confidence interval for the slope in this population. Now, you might be looking at this, and you might be saying to yourself, there's a data table right next to it. Do we need that? The answer to that is almost no. Almost. I say almost because, I mean, you need like one piece of information for it, and that's really it. But to make this 90% confidence interval, the fastest method of that is to use the formula for it, which, let me quickly write that out before actually doing anything else. Since my answer key already has the actual lovely big giant long wordage of it, but we take the slope, we add and subtract the t-score for this 90% confidence interval. In this case, I'll put 0.90 here, just to indicate that's the t value for that confidence. And we're going to multiply that by the standard error. And I'm going to do it in Excel just because obviously I am not going to know this number offhand. But we were told in this problem the slope is negative 0.0896. So let me put that in here first. And I'll do the lower bound first. So I'm going to subtract the t-score for that 90% confidence. This will be t.inv 2t due to the fact there's a confidence interval we take 1 minus 90%, so 0.1 or 0.10, and then comma the degree of freedom for this. There are a total of 8 entries in this table that I failed to actually show the entirety of. So because there's 8 here, we're going to subtract 2 from this 8 for the degree of freedom. So this would be a 6. And we're going to multiply that by the standard error, which it said was 0.026. Again, that would be the formula for the lower bound. And the upper bound is the same thing, but with a plus. Okay? So I'll give you a few seconds to copy down that lovely looking formula before actually hitting enter onto that, and then, it no longer being visible.
Will the 6L formula be on the answer key that you put in Blackboard?
This formula is actually not on the answer key. As you could probably saw by the way I had to write everything in there. Some of these questions are on the longer-ish side, and I unfortunately didn't have much room for several of these calculations, hence why they're not in there. So my apologies for such a long response to said question, but no, that formula is not on that sheet. The answer is just not the actual formula. And the 6 came from, there were 8 here, 8 total entries. This 6 is the degree of freedom for the t-score. And because we were doing the confidence interval, we need to subtract 2 from this value. So the degree of freedom for this t-score for the confidence interval around the slope, we need to subtract 2 from the sample size. So 6. But if I were to hit enter onto this, it will give you the lower bound of this confidence interval, which was negative 0.140. And the upper bound is negative 0.039. Oh, and this, a lot of the time on this particular exam, they're going to make you round to either 2 or 3 decimals. So just be aware, I didn't just choose this rounding just because I feel like it. They're going to make you do that, and you know how that gets. So be aware of that. Do all of you need me to write out the actual conclusion from this? Or all of you found with that?
Will we need to write out the conclusion, like since it's through my math lab, or will it mostly be fill-ins?
Most of it's a fill-in. There's like a couple, it's either a multiple choice type of thing, or you have to like fill in very small specific parts type of thing. So like this one, I believe was you have to, well, in this particular one, let me rephrase that. You only have to type in these 2. They give you the parentheses, which is what I did. And this would be a multiple choice as to the interpretation of the confidence interval. In this question, you don't have to type anything into that part. I don't know if that's any help. The number of questions of the test are the same number that are on this review sheet. So I think I have 22. 22. So 22 are the amount on this lovely test. But I could read out what this actual interpretation was, which is on average, a student's GPA decreases by between the lower and upper limits of the confidence interval for every additional class skipped. Very wordy. I know. I don't think I would have asked you to use that many words if we were actually on campus for that, but that's what that interpretation is. Any other questions about this particular type of thing? And don't worry, there's a second one of these later on as well, which we're probably not going to get to, but same idea. Alrighty. So this was number 2. Again, I don't think, anyway, I did anything too drastically bad about it. The only thing you need to keep in mind is ignore this table. You do not need this table at all. And that's a terrible thing for me to say. I know. But I'm just being honest so you're not wasting time during the middle of the final. It's going, he didn't tell us anything about this. There's a reason for that. Anyway, question number 3 here. Jan's all-you-can-eat restaurant charges $8.70 per customer to eat at the restaurant. Restaurant management finds that its expense per customer based on how much the customer eats and the expense of labor has a distribution that is skewed to the right with a mean of $8.10 and standard deviation of $3. If the 100 customers on a particular day have the characteristics of a random sample from their customer base, we want to find the mean and standard deviation of the sampling distribution of the restaurant's sample mean expense per customer. So those formulas, well, one formula, the other one's not really a formula, but the mean of the sampling distribution is the same as the population mean. And we were told in this question that the population mean is $8.10. And I clicked the wrong button. Awesome. So that means this mean is $8.10. The standard deviation of the sampling distribution takes the population standard deviation, divides by the square root of the sample size. And this actually gives a nice number, right? Population standard deviation is $3 divided by the square root of 100. Square root of 100, you technically don't even need a calculator for that if you don't want to use one. That just makes 10. This will give us a standard deviation of 0.3, or 30 cents, I guess is a way I should probably say it. In this question, they'll just ask you for these two. So there's a sentence that says the mean is, and you put $8.10, and the standard deviation is, again, you put 30 cents. So for that particular part, that's not bad. I don't think, at least. Any questions about this? Again, this is something we talked about, right around the beginning of this moving to online. So it's been a while-ish. You might notice that a lot of these questions do tend to stem from stuff we did after moving to online. You might notice that. That was designed by choice. So that's just that part. Again, not the worst question on this particular exam, at least. Part B, though, wants the probability that the restaurant makes a profit that day, with the sample mean expense being less than $8.70. As much as I would love to go draw out a nice, lovely looking picture for this, it doesn't ask you for anything like that, so I'm not going to waste your time with it. But this essentially means we want the probability that X bar is less than $8.70. Is what that wants. And the Excel formula that accomplishes this, and I'll just write this one out, it's norm.dist of $8.70, the mean of $8.10. I'll have to move this. Standard deviation of 30 cents, and then true. When you type that into Excel, you'll get the lovely answer to it, which, you know what? I'll draw the picture very quick. This had a mean of $8.10. $8.70 is like here-ish. So we want all this area here to the left of that. And if you put that into Excel, since as you can see, it's kind of a lot there, this probability is pretty high, 0.977. Do any of you have any questions about that? Again, you will not be asked to do anything with a drawing or anything like that. Unlike the last time you had this, which did. But that one also, physically wrote out more than that. Alrighty. Again, this is the same type of wording that you'll see on the final. Hopefully these numbers change. That'd be very embarrassing if they didn't. But I can't physically control that right now. Question number 4, and this one starts using these hypothesis tests that we just were talking about before the end here. For a new pesticide, should the Environmental Protection Agency, EPA, bear the burden of proof to show that it is harmful to the environment, or should the producer of the pesticide have to show that it is not harmful to the environment? The pesticide is considered harmful if its toxicity level exceeds a certain threshold, and not harmful if its toxicity level is below the threshold. Consider the statements: the mean toxicity level equals the threshold, the mean toxicity level exceeds the threshold, and the mean toxicity level is below the threshold. Which of these statements should be the null, and which the alternative hypothesis, when the burden of proof is on the EPA to show that the new pesticide is harmful? This one is also not an actual typing one. This is a choose from 3 answer choices. And those 3 are equals, exceeds, and below. So I am going to abbreviate these because you are not actually writing them out. The null hypothesis for both of these is going to be that the mean toxicity level equals the threshold. So I'm going to be like this and just put the word equals in here, since everything else in the wording stays the same. That's equals. Since we want this to be harmful, this would be an exceeds the threshold for the alternative. Likewise, for the if the burden of proof is on the producer to show that the pesticide is not harmful, it has the same null hypothesis. So let me write that out. But the difference with the alternative now, since we want to show it's not harmful, this would be it's below the threshold. Again, I'm going to be like this and just write the word below, since that's what it'll be. Any questions about either of these two? Again, it'll be 4 answer, 4 spots where you choose an answer. And 2 of them are equals. The first alternative is exceeds, the second is below. And then naturally the wording will be pretty much the same thing. This one I didn't change up that much. Alrighty. Well, that was number 4. Again, this one's not going to be that much different. Question number 5, and I should have left myself more space for this. I just noticed that. Question number 5. You must pick one of 2 wagers for an outcome based on flipping a fair coin. You win $440 if it comes up heads, and lose $110 if it comes up tails. And then you win $660 if it comes up heads, and lose $220 if it comes up tails. You want to find the expected outcome for each wager, and which wager is better in this sense. This, despite the fact that it does not explicitly state this is the probability. This is the, we want to find the mean of this discrete random variable. And if you remember back from when we talked about this, we take the value of that random variable and multiply it by its probability and add them up. There's only 2 for each one though, so I didn't choose an exactly bad one for this. The previous version that I had was a lot worse. Trust me on that. But for this though, for at least this first one, you win $440 if it comes up heads. So take 440. The probability of it being heads is 1/2. And you lose $110 if it comes up tails. So just like the examples we did many months ago, this would be a minus $110 times the probability of it being tails, which is 1/2. And if you put this into a calculator, this is the first wager. I should have identified that. First wager, if you do this out, this makes $165. So again, for this, you're only typing in $165. Excuse me, 165. Just that. There are no decimals in this answer. The second one's very similar, as you could assume. $660 if it's heads. So 660 times probability of it being heads is 1/2. And lose 220 if it's tails. So minus 220 times probability of tails, which is 1/2. Again, toss that into a calculator, and you get an answer of 220. That is a coincidence, by the way. And well, you could tell the answer by the 2 answers here that you got, but which wager is better in this sense? That'll be the second wager. Any questions about this? Again, it's just a direct interpretation of this formula. Alrighty. Again, just that formula. I didn't do anything too tricky, I don't think, at least. But you would all be better judges of that than me. I feel like I might be biased in that regard. But that's number 5. Question number 6 is a long one. Very long. You might be able to tell that by just looking at it. There's like, what, 1, 2, 3 parts? 3 parts, but some of these have multiple parts to each of those parts, especially A and C. And so it's actually probably better for me to type this than it is for me just to physically write. Again, it's long. But for number 6, I have, in a study of binge drinking, the percent who said they have engaged in unplanned sexual activities because of drinking alcohol was 25% in 1993, with a sample size of 152, and 29% in 2005, sample size of 483. And we want to know, is this change statistically significant at the 5% level, significance level? And we want to specify the assumptions, notation, and hypotheses for the two-sided test. You could find all this wordage on that PDF that I gave out, but to write it all out, since there's one portion that you have to choose from, but this is each sample must have at least 5 outcomes of each type. And they specify, success and failure. The data must be, and let me underline this because this is an answer choice option, categorical, not quantitative, not numerical, categorical, and it'd be helpful if I could spell categorical. There we go. Be helpful if I could spell. Data must be categorical, and these samples must be independent, random samples. So the only part of that you actually have to fill anything in is the word categorical. The rest of that comes pre-written out for you, which is nice. So there's that part for the assumptions. The notation aspect of this. This one, I believe you have to... This one's an answer choice one for the notation. The notation of P, that is the proportion who say they had engaged in unplanned sexual activities because, wow, I cannot spell today, activities, because of drinking alcohol. Again, that's an answer choice option. And then the last one, they would want you to specify the null and alternative hypotheses. The null hypothesis is that these two proportions are equal. And since they want to know, where is it? Two-sided test. The alternative is that they are not equal. Do any of you have any questions about that? Alrighty, so this would be an example of one of these ones that needs either the template or one of those web apps that I showed before. Again, those links are on Blackboard. But I'll show the template since that's what we've been using before. And I certainly hope you all use, but I can't force you to, I can't force it to work for you, unfortunately. Come on, let me move you. Oh my goodness. There you go. So this one I have 25% in 1993 for a sample size of 152. So 152 goes in the sample size. The number of successes, this is given as a percentage, not as an actual number. But to make sure we get the actual value for this, I'm just going to do 152 times 0.29. Oh, you're not going. There we go. I did 152 times 0.29. I forgot the equal sign for that one. And the second one, this will be 483. And number of successes, we want that to be a... I used the wrong number, didn't I? We want this to be 25. I put 29. We want this one to be 29. Okay, so I just multiplied by the percentage to find both of those. Why did I want the exact ones? The calculations are slightly nicer. Whether or not you have the actual number tends to be helpful, but you know, there's always that. So both of those go in there. And we first want the standard error. Well, excuse me, the pooled estimate of the proportion to use in the test. So pooled proportion would be this value on here. And if you use one of those other templates, it will be on there as well. So this gives it as a percentage. They want you to write it as a decimal. Please bear that in mind. As a decimal, this pooled proportion, p hat, is going to be 0.280. It's going with 3 decimal points. So I'm writing this percentage in decimal form. Bear that in mind. Any questions about this part of that? And let me very quickly turn off that incredibly annoying phone. There we go. So that's part B. Part C. Part C, and I do not want that to go on. Part C, I want the test statistic and p-value, and then make a decision using the significance level of 5%. Again, this is going to be a very wordy answer. But we were given the test statistic in, let me find it here, negative 0.96. And the p-value, which I did not make this larger. Let me not use that. P-value is down here all the way at the bottom. So 0.338, blah, blah, blah. This one's going to make you round both of those to 2 decimal points. So this would be negative 0.96 for the z-score. I'll write it up here to save myself room. And the p-value, also rounded to 2 decimals, is going to be 0.34. And then the actual decision and interpretation at the significance level of 5%. Again, I'll do my best to write this entire thing out and note where there will be answer choices. This is a we do not have And why does it do not? Because the p-value is well above 5%. We do not have sufficient evidence to reject the null hypothesis. We do not have sufficient evidence to reject the null hypothesis. We are unable to show that there is a difference in proportions of reports of engaging in unplanned sexual activities because of drinking between 1993 and 2005. I know, very long-winded responses. Imagine what mine would have been if we were actually at college. But can't go on second guessing with that currently. Any questions though about any part of this particular question? Feel free to tell me if I'm going too fast with it. But as we all probably tell, I am not finishing this entire sheet. No questions already. Well, that was that was question number 6. Question number 7. Question number 7. I kind of enjoy question number 7, but also kind of not. It makes you do one thing in it. Well, question number 7. I give a data table, which this time we need to use. We need to use that data table. But this is, ideally, results of a statistical analysis should not depend greatly on a single observation. For the weight changes in a table from an anorexia study, the greatest reported value of 20.3 pounds was a severe outlier. That 20.3, I highlighted it in the version I posted online, but it's right there. Was a severe outlier. Suppose this observation was actually 2.3 pounds, but was incorrectly recorded. The original results of the test resulted in a test statistic of 2.19, p-value of 0.037, and rejected the null hypothesis. We want to redo the two-sided test of the null hypothesis of the mean equaling to 0 with a significance level of 0.05 and summarize how the results differ. And then, does the ultimate conclusion depend on that single observation? You could probably guess the answer to that by just the fact that you're doing this problem. But that's besides the point. The alternative hypothesis for this, I'll write it over here, is that the mean is not 0. But let me very quickly get this data so we can actually do this particular problem. I pre-wrote this out though, so I don't have to actually do that right now. There we go. And let me take this and put it into the template for that one main template. Again, you can use the online version if that's easier. Oh, where am I? Here I am. After putting that in there and changing the value of 20.3 to 2.3. Can't forget that before going on. So changing that value, we have, where was it? the test statistic changing to 1.95. And the p-value, which I do not have on the screen, this is a not equal to measurement of 0.0, how much does it round to? 3, excuse me, so 0.062. And again, very witty response. This one I should have left myself more room for. But let me write this one out. Since, again, several parts. This one has a bunch of places to type. Well, I shouldn't say type. Bunch of places to choose answers from. So, this being the p-value is greater than the level of significance, which we could see since 5% is indeed less than 6%, so p-value is greater than that level of significance. So that the oh wow, I'm on the wrong area. So that the p-value is greater than the level of significance, so do not reject the null hypothesis. There is not significant evidence that the population mean is not equal to 0. That's the overall conclusion, not the secondary conclusion. Oh no, that sounds very weird of me saying it. That's the overall conclusion. The secondary conclusion, and I hope this does not go to the second page on me. Oh, it's going to. Never mind. After changing 20.3 to 2.3, the test statistic decreased. Test statistic decreased, and the p-value increased. And the p-value increased. You could tell that because, and I'll go back down to it in 1 second, bear with me. The test statistic was 2.19 and decreased to 1.95. The p-value was 0.037 and increased to 0.062. That's why it's those two. P-value increased. Period. In the original test, the null hypothesis was rejected. We were told that in the original question. And after the adjustment, the null hypothesis was not rejected. The conclusion does I don't want that. The conclusion, oh my, does depend on the single observation, which you could have just guessed by the fact that I even asked you to complete this question. So that's the point, though. I know it's a very long-winded answer. You could probably have rest assured that if we were actually doing this on campus, I would not have asked you all of these different parts. Some of it, yes, but not all of that. Any questions there about this? And by the way, I see the time. I know we're very close to the end. I wanted to make sure we got through that particular question. But as you could probably tell, we only got through, what question was that, 7? There's 22 in this packet. I provide all the answers. Of course, though, you know, some of these do tend to have formulas and whatnot that go along with them, which, as I said, are not inside of the current in the current answer key. So after this class, and again, after I do my other class also, I'll have to probably record a bunch of videos going over these remaining questions, since I have, again, 22 of them here. But from what we did in this lovely short 50-minute class session, were there any questions, thoughts, concerns, complaints that I failed to have addressed?
The final exam, if we send you like work, can you give us partial credit?
Yes, I did not say that yet. I probably would have not said it anyway until like the day of. But yes, if, you know, as you're taking the exam, you know, feel free to write things down and send me that for partial credit, yes.
Are the Excel templates on your webpage?
The announcement I made today has all the templates on it and alternative templates in case those ones do not work.
Awesome.
As you can tell, I was prepared for once. That's a good thing. Any other questions?
In Pearson, there's like 2 homework assignments throughout this week. Are those like required?
What do you mean by required?
Well, so there's like a homework assignment due like Wednesday and Thursday. Or like we'll be taking finals then. So.
Ooh. I mean, I do have the due dates for those days, yes.
Okay.
Yep. Any other questions?
Will you be holding office hours tomorrow or on Wednesday?
I was not physically intending to, but I mean, if you certainly want to meet with me with any questions or anything, we could certainly go about scheduling that.
Okay.
I know I could be a very vague person. I don't intend to be. It just happens naturally.
So you're gonna send us the formulas for the rest of the questions?
Yes, not immediately, since I do have to do my other class, but yes, I will be sending that later.
Okay, thank you.
You're welcome. Any other questions as I go to turn this off? Alrighty, well, thank you very much for coming to our this class session right before final exams. As I said before, that it did take me 43 minutes to complete it, so it's not something that's entirely uncompletable. But, you know, you do have 3 hours to take it, so there was that as well. I will be sending you all of you those videos and whatnot, going through how to do these. Once I, film them and everything, so that will give me a little bit of time to do that. But they will certainly be out. I want to say probably tomorrow, at the latest. But we shall see. All of you have a good rest of your afternoon, and yeah. That once you do that lovely final exam, that'll be it for the semester. So have a good rest of your day, everyone.
Thank you.
Thank you.
You're welcome.
Thank you, Professor.